Okay, this should be the last step in our last video for our creation of a parametric Lego brick. So I've got the Lego brick up in front of me. We created our parameters in the last video. So modify, change parameters. There they are. Click OK. Got my timeline down here. We're going to go through the timeline and we are going to update the elements in our timeline. We're going to edit those features and sketches, and we are going to change them from hard-coded values where we typed in numbers to our parameters. Okay, so let's start off with the first sketch. Edit sketch. Okay, I've got my 32 up here for my length, and I've got 16 for my width. I'm going to double click on my 32. I'm going to change this to length times spacing. So length, as I start typing length, looks what comes up for me. Hit enter, space. The operators. What are the operators? The operators are the symbols that represent multiplication, addition, subtraction. In this particular case, the arithmetic operators. What is the operator for multiplication? It is the asterisk, shift 8. Length times spacing. I'm going to hit enter. Go slow there. Okay, so brings 32 back up so that my calculation is correct. Length was at 4, spacing's 8 millimeters. So my length is now 32 millimeters. 8 times 4 is 32. The fx is now appearing in front of it. Notice my 16 is just a straight number. The fx means I've added a function to this, okay, that it is dependent upon a parameter. And my parameter is actually a formula. Now, we're going to do the same thing with width. Double click, width. Space. You don't have to put space in. Times spacing. Enter. And there we are, fx. Okay, so both of those dimensions have been updated in my sketch. I'm going to finish sketch. Move on to my extrude. Edit feature. Let's go home, or where we can see it. So that's the extrusion of the height of my brick. And I want to set that to height. There it is. And that one's updated. My second sketch, that's where I sketched the top pen and position that first one. Oh, that's not sketch. Right there. Edit sketch. Roll it over so it's in the right corner. I've got 3 elements in here that I'm going to change. My first one, second one are my positionings. So that's position. Remember, we set position to be the 4 millimeters that we are going to position our pins from the edge, our outer pins. So now they both have an FX. The diameter of my top connectors, it's a top connector variable parameter. So it's going to start with TC. So I start to type my TC. There's TC diameter, select it, enter. All 3 are changed, finish sketch. The extrusion, edit feature. Move this palette. So there it is. I'm going to click in my box. It's a top connector again, so it's TC height. See, if we were working in a complex design and had many different dimensions in there, that naming convention would makes it a lot easier to find what you're looking for. All right, so that's updated. The fillet, we didn't create one for that. We're not going to worry about it. The rectangular pattern. This one gets a little harder. Let's edit the rectangular pattern. Okay, we've got our two features selected. We're not going to mess with that. We've got our axis selected. The quantity. The quantity, how many pins do we have in a row? Length. The distance. Okay, now we're going to get a little mathematical. So we know the distance, spacing times. It's going to be length minus 1. We have 4 pins, which creates 3 gaps of 8. This holds true always. Okay, the number of gaps that we multiply by the spacing is always 1 less than the number of pins. Now, why am I going to open this and put it in parentheses? Length minus 1. Why would I put that in parentheses? Order of operations should be a term that you're familiar with from your math classes. It's going to do multiplication first. I want to control it so that it reduces length by 1 and then does the multiplication. Okay. Quantity over here on the axis 2, going on the width side. So guess what? It's going to be width. That's the number of rows. And the distance will be spacing times the quantity of, so it's in parentheses, width minus 1. Okay, that's it. That handles our, everything's been converted to a variable here. All right, we're good. Click OK. And we still look the same. That's good. So that's done. The shell, that's our wall thickness. I'm going to edit that feature, and I'm just going to put in wall. We're updated. The last sketch here, roll it over so we can see it. Edit sketch. All right, there's our 5 millimeters for our center diameter circle. That's going to be TC diameter. And the thickness of our BC wall. Well, it went the wrong way, didn't it? It was -1. Well, let's change that. So BC wall, our wall thickness is 1 millimeter. We put that right, but we want it to go the other direction. So all we're going to do is multiply it by -1. Fixed. All right, finished sketch. Home position. The extrusion. We extruded that to be equal to the bottom of the brick. So we do not have to modify a variable there. It's already contingent upon the height. If we change the height of the brick, the bottom the relationship changes, the bottom connector height will change. Now, here's our problem child. We've only got 1 row. So it's when we edit this, there's nothing here in axis 2. It's going to mess up when I go in and change it to multiple rows. So I'm going to delete it and we're going to redo it. But the first thing we're going to do is we're going to our parameter table and we're going to change our brick from a 4x2 to a 4x3. That way we'll have, with our bottom connectors, there is always one less bottom connectors in a row than there are top connectors in a row. So if we've got 4 top connectors in a row, the bottom connectors will have 3 in a row. If we have 4 rows of bottom connectors, or 3 rows, let's go 3 rows because that's what we're using. If we have 3 rows of bottom connectors, we'll only have 2 rows of bottom connectors. 3 rows of top, 2 rows of bottom. I think I said that wrong the first time. Okay, so let's click OK. Let's leave that this way. 4 by 3. Now let's go back and add our rectangular pattern again on the bottom. Okay, so there we are. Seems like that. Oh, I didn't flip it last time. That's why. That's all right. It'll work. It makes you feel better. We'll turn it around. Okay. That's still not it, is it? I'm wasting time, aren't I? Let's just do it this way. All right, rectangular pattern. Now, we are going to once again use a feature. Right there. There's our extrude. So I changed it to feature. All right, our axis. Let's select this line. And there we go. All right, so this is going to be length. We don't want 4 though, do we? We want length minus 1 because we only want 3. Our distance will be spacing times quantity length minus 2. Why minus 2? Well, we're reducing length, which is our number of top connectors, by 1 to make it equal to that's how many bottom connectors we have. If we've got 3 bottom connectors, we've only got 2 gaps of 8 in there. So we have to reduce it by 1 more. Let's grab the arrow going the other direction. And this will be the width minus 1 and times the quantity of width minus 2. Enter. And there we are. So let's go back to the home position, modify, change parameters. Let's go back to our 4 by 2. That looks good. Let's roll it over and see. Yep, down to 1 row. Let's go to a 10 by 6. Our length adjusted appropriately. Our width is adjusted. All right. Our number of bottom connectors has adjusted through our formulas. We can create any size brick we want to now based upon the parameters that we've created. All right, submit your work. Look to Rockspace for the screenshots required. And that is it for the parametric Lego brick.